Hey, and welcome to another physics lesson. In this video, we are going to cover acceleration. Acceleration is the rate at which the velocity changes. To calculate the acceleration, we have to know a few variables. Since the object is changing velocity, it must have an initial velocity, which is represented by the variable vi, and a final velocity represented by the variable vf. In addition, we also need to know how much time it takes to change from the initial to final velocity. The equation for acceleration is final velocity minus initial velocity divided by the change in time. The variable a represents acceleration and has a vector notation over it, implying acceleration does include a direction. Let's try our first example. A car driving north wants to catch a yellow light by speeding up from 15 meters per second to 25 meters per second in 2 seconds. What is the acceleration? We know the equation for acceleration. Next, we should determine all the known information by breaking down the wording of the problem. Since it says speeding up from 15 meters per second, this implies a starting velocity, and therefore 15 meters per second would be the initial velocity. Continuing with the wording of the problem, it states from 15 meters per second to 25 meters per second. The car ends with 25 meters per second, and this would be the final velocity. Lastly, this change in velocity happens in 2 seconds. With all the known variables, we can solve for the acceleration. 25 meters per second minus 15 meters per second divided by 2 seconds gives us positive 5 meters per second squared. Something else should be noted here. Since the velocity and acceleration have the same sign, this also means the object is speeding up. Let's try a second example. A biker riding at 3.49 meters per second east comes to a stop in 8.0 seconds. What is the acceleration? We can write down what we know. The initial velocity is 3.49 meters per second. The biker comes to a stop, which means the final velocity is 0 meters per second. Lastly, the time is 8.0 seconds. Put in the known information, and we end up calculating 0 meters per second minus 3.49 meters per second divided by 8.0 seconds. The acceleration is negative 0.43 meters per second squared. The velocity and acceleration in this problem are opposite signs, which means the biker is slowing down. Here are a couple last notes regarding acceleration. If the sign of the velocity and acceleration are the same, it implies the object is speeding up. If the sign of the velocity and acceleration are opposite, it implies the object is slowing down. Hope you found this video helpful, and thank you for watching.